Welcome to the Mönster Lab. Mönster here stands for Molecular Nanoscale Energy and Transport Laboratory. I'm Teng-Fei Luo. I'm a professor at Aerospace Mechanical Engineering, and I'm directing this lab. In this lab, we have a group of undergraduate and graduate students, postdocs, and research scientists working towards the same mission for scientific research. So in this lab, we study the fundamental nanoscale and molecular level energy and mass transport. So we use methods like theory, simulation, AI, machine learning, as well as experiment. And then we apply what we have learned from these fundamental research towards diverse applications. For example, the electronics thermal management, energy devices, water desalination, biosensing, as well as additive manufacturing. Our research touches the matter as deep as under the sea and as high as in the space at the International Space Station. Welcome.
Hello everyone, my name is Ty Milazzo. I work here in the Mönster Lab run by Dr. Teng-Fei Lu. I'd like to show you a little slice of what we do here, and this is the material and chemical side of the Mönster Lab. So first thing I would like to start off with is our own material processing. Here in the Mönster Lab, we like to not only design but build and maintain a lot of our own instruments. We are currently testing a lot of different polymers and trying to find new materials that relate to heat dispersion as well as clarity. And this is just to help for not only commercial use but industrial and hopefully even space usage. So we have a machine here that we use to roll out and make very thin, small polymer sheets. And as we go around here, we have more instrumentation as we get to larger and larger presses, where if we have thicker, more durable polymers, we like to press them down with heat or just with pressure. We also, in this lab, look at a lot of the chemical side of things. Currently, we're looking at ionic liquids, so we are prepping a lot of vials to go through a lot of our ionic liquid processing. As we go around here, we have our procedures set up. We have a lot of collaborations with different departments. The one we like to work with here is the chemical and biochemistry department, who help give us a lot of the different chemicals we have here. So if you look over here, we actually have some of our processes up and running as we're looking at extraction with water. And we can even see at the bottom here more of that polymer buildup that is being tested over in the materials section. We have a lot of different in-lab materials and instruments. We have a heated press over here for materials and a centrifuge over here to help get and test our ionic liquids and their separation. So this is the little slice of the Mönster Lab's chemical and material sciences, and we would hope to see you soon, as the Mönster Lab has a lot of variety, and we can definitely look at your project and get you a lab that suits you best.
Hello everyone, I'm Zhihao Xu, a graduate student in the Mönster Lab.
I'm Zhao Hangzhou, also a graduate student in Mönster Lab.
Here is our office. We mainly do our computational research here. Our group mainly do some molecular level dynamic simulation and first principle DFT calculations to research on the material science. We have found a lot of interesting things related to the thermal transport in different materials. And we also have some data-driven methods for observing and discovering the new properties of the material.
We study the fundamental physics of energy and mass transport from the nanoscale and molecular level. We use theories, simulations, and data-driven approaches to do it. We have, for example, the physics-informed machine learning, and also we have some other data-driven method. We have collaboration with Intel and Department of Energy.
Hi there, this is our optical lab, and we're from the Mönster Lab under Dr. Teng-Fei Lu. I'm Amartya Mandal, and he's.
Hi, my name is Zhen Chang. I'm the second year PhD student.
Arguably, the most important part of an optical lab is the lasers, and here is the most prized possession of ours. This laser is a femtosecond laser. Its wavelength is 800 nanometer. This can deliver really short pulses, up to 94 femtoseconds. This is another laser. This 532 nanometer green laser. This laser is much powerful than that laser. But this laser is not a femtosecond laser, it's a continuous wave laser. Here we have another laser. This is a kind of a baby laser. This is a blue laser. And this laser is not as powerful as the other lasers, but it gets the job done.
Hi guys, this is the setup part. The first layer is for TDTR. This is a setup for material thermal conductivity measurement. Okay, then this is the second layer for the nanoparticle deposition. We move the stage back and reflect the laser beam to the second layer, and this is the beam path of our setup. We have the high-speed camera to visualize the bubble generation process, and we put our sample here to shine the laser and generate a bubble like this. The bubble size is like about micrometer size, and once the bubble shrinks, we have the deposition.
This is a very small tour of our optical lab. We hope to see you guys soon.